And then our next question is asked to sketch the curve for f of x equals 1 over 1 plus e to the negative x. Right, the exponential function, but not that much. Right, well, first of all, domain. Right, domain is the denominator cannot be equal to 0. That, well, e to the something cannot be negative 1. Right, but we know that e to the negative x is this exponentially decreased function, that it will never be negative 1, so no solution. Right, to keep it as negative exponent is fine, we don't have to simplify. Right, if you want to simplify, you can multiply by e to the x to the top and bottom, which is a little similar, right, but not necessary. Right, we get directly from that question is also able to do. So for the domain, it's all real number, that no solution of x can make the denominator to be 0, so every value is able to be taken. All the value of x are able to be taken. Right, then of course domain is everywhere. The next one is x-intercept and y-intercept. X-intercept, we let this e to the negative x equal to 0. Right, even though you simplify, right, that cannot have solution. Before we simplify, we have just the numerator equal to 0, that's no solution. So we will not have any x-intercept. And for y-intercept, we're going to have is f of 0, that is 1 plus e to the negative 0, that is 1 over e to the 0 is 1. 1 half. Right, so we don't have no x-intercept, but y-intercept is 0. 1 half. Right, that's our intercepts. And then about the asymptotes. Of course, domain is everywhere. We will not have any vertical asymptotes. Vertical asymptotes depend on what's the domain where the function is undefined, and for rational function has possibly be the vertical asymptote. But this function originally defines everywhere, so we do not have any vertical asymptotes. Right, then for horizontal asymptote, I believe we have seen the example before, right, to take the limit as x approaches to negative infinity. That we take negative infinity of x, this one will be infinity, right, e to the negative x is infinity, that we get it to be 0. And when x to be positive infinity, we get e to the negative x has the value of 0. Since e to the negative x looks like that, we have just mentioned already, right? That's the graph of e to the negative x. E to the negative x. Right, then we have the 1. So, no vertical asymptote. The horizontal asymptotes are y equals 0 as x approaches to negative infinity, y equals 1 as x approaches to positive infinity. Right, so 0 from the left, 1 from the right, in the middle we don't know yet what it looks like. Right, Then for increasing decreasing interval, we do our f prime and f double prime thing, right? F prime. So f of x, that is 1 plus e to the negative x to the negative 1. Right, therefore f prime of x, that's negative 1 plus e to the negative x times negative 2 multiplied by the derivative of inside e to the negative x times negative 1. Chain rule. The inside derivative is 0 plus e to the negative x, but e to the negative x is have the derivative of the power is negative 1. Right? Chain rule step by step. That we can multiply the negative cancel out, we get e to the negative x over 1 plus e to the negative x squared. Right? If you can try that to simplify, multiply by e to the x, that e to the negative x will be cancelled, we'll get e to the x over e to the x plus 1. That you can use quotient rule to find the derivative. Here, before simplify, we just use chain rule to find the derivative. That f prime of x is e to the negative x over 1 plus e to the negative x squared. Right. Of course, it's always beneficial to find the derivative of positive exponent, that maybe the negative 1 will be not being necessary to show over there. Right, but anyhow. Right, so this defines everywhere. So when we find the critical numbers, we just need to solve for f prime x equal to 0. Right, this function itself defines everywhere since the denominator is the same denominator we have. Right, so we don't need to specify more or solve more things. We just say defines everywhere. Then we do the f prime of x equal to 0 to show that, well, we get e to the negative x is the numerator equal to 0. Therefore, negative x should be 1. No. E to the negative x equal to 0, that we actually have no solutions, right? Negative x, actually no solution. E to the x can never be 0, as we see before. It could be 1, but cannot be 0, that it never touches. Right? So we don't have any solutions. So for that function here, we do not have any extrema. No relative extrema. Which means the sign is unique. When we get the table from negative infinity to infinity of the interval, we could put test value at any value, maybe 0. Then for f prime and the original function, we could see. Or even we don't have to do that, right? But let's see. If we put 0, that's e to the 0 over 1 plus e to the 0 squared, which numerator we get 1, denominator is 2 squared. Positive. Which yields the function to be increased all the way. Right, so from negative infinity to infinity, that function is always increasing. Right? That's what the conclusion for the f prime, and for the increase decreasing interval, it increases all the time. And then to find the second derivative, Well, we get f prime of x is e to the negative x over 1 plus e to the negative x squared. Then we find that the second derivative will be a little more trickier. Much trickier than finding the first derivative. We let u and v. U prime is simple, that's e to the negative x times negative 1. V prime, that's twice of 1 plus e to the negative x times e to the negative x times negative 1. Right, to apply the chain rule, right, the power first, then the inside, copy down the first power, multiply by the derivative of inside, which is e to the negative x, and derivative of power, that's negative 1. That's negative 2 e to the negative x, 1 plus e to the negative x. Right, so much steps, so many steps. Then f double prime of x, that's 1 plus e to the negative x to the fourth power, u prime times v minus v prime times u. That what we can do is, well, cancel out the 1 plus e to the negative x of every terms. That we get it's 1 plus e to the negative x to the third power. Since it's all positive, right? That the denominator is negative e to the negative x, 1 plus e to the negative x, plus 2 e to the negative x times e to the negative x. Why I do that is because, well, I'm able to factor out the e to the negative x. Negative x to the third power, factor out e to the negative x. I get negative 1 minus e to the negative x plus 2 e to the negative x. I factor out the e to the negative x once. Then I have negative 1 minus e to the negative x plus twice of e to the negative x, which at the end e to the negative x times e to the negative x minus 1. Right, that's our second derivative. That is our second derivative. So the purpose to find our second derivative is to get the possible inflection point. Right, we get second derivative to be e to the minus x, e to the minus x minus 1 over e to the 1 plus e to the minus x to the third power. Again, this thing defines everywhere. But this one defines everywhere. So possible point of inflection is, we say defines everywhere, we just need to find, well, double prime equal to 0, which we take the numerator. That e to the negative x will never be 0, so e to the negative x minus 1 equal to 0 is possible answer. Which, if the power of exponential function equal to 0, we get a 1. Then negative x to be 0, that x is still a 0. And we found out the f of 0 already in our original question. Right. The possible point of inflection is at x equals 0. So 0, 1/2 is possible point of inflection. Right, then we just cut the domain by x value of the point of inflection, that it cuts from -infinity to 0 and 0 to infinity for the test value, and for the f double prime, and for the f. But one thing we could consider that f double prime of x, we have e to the negative x is always positive, the denominator is always positive, only the sign of e to the negative x minus 1 is unknown. Right, so for every value before 0, e to the negative x is bigger than 1. Right, if we put -1, that's e minus 1 is a positive. Positive number times e minus 1, which is a positive number. And for the number after 0, it's negative. Right, so if we put 1 there, that's 1 over e minus 1 is negative. Right, other two are positive. Right, for the one that's the uncertain term, we get a negative number. So overall, we have concave up and concave down. Overall, we have concave up, concave down. And well, change concavity, so 0, 1/2 is the point of inflection. Right, is our inflection point. Right, so to wrap up, we have only one certain value that is at 0. Everything else for the increasing decreasing interval that's consist. Right, or in other words, that's monotonic. Right, so we are able to find just the interval or the shape of the function by f prime looks like increase all the way, double prime sets the function as concave up and concave down. Then at the end our function will be increased concave up and increased concave down. Right, so finally we have -infinity to 0, 0 to infinity as the interval, increase concave up and increase concave down. Right, that is the final shape of everything we have. Right, so everything we do, we find out the final shape of the function, and with the relative extrema and the inflection point of inflection. Then finally, right, to draw the curve, we have the vertical, nothing horizontal asymptote is at y equals 0 on the left, and the y equals 1 on the right. We have the 0, 1/2 is our y-intercept, and also the point of inflection. Right, the point of inflection. Right, there's also that. That is 1 here, 1/2 is in the middle. 0, 1/2 as this point. Right, then nothing else, right? That is the only thing we have. So sketch the curve. Before 0, that's increase and concave up. So increase and concave up to this point. And after 0, we have increase and concave down, right, towards the horizontal asymptote. Right, so we have y equals 0 as the horizontal asymptote, and the y equal 1 is our horizontal asymptote. The point of inflection y-intercept is at same point, and nothing else needed to be specified for this question. Right, so that is our function here. That is the full step, and of course finally range is from 0 to 1. We are not able to take the value 0, not able to take the value 1, but everything in between we're able to take. Right, so that is this question.